So again, another quote. So it says, to tell your friends exactly that, I like this. So this was said by this lady here who was on the design team of the like button that you see in Facebook. Okay? So these are the thoughts and the efforts that have gone into developing this interface that you and I know of today. So there's another statement, everyone is distracted all of the time. Again, an associated comment. So this is by Mr. Rosenstein, who was in the design team of the like button. So there is actually a Quora post that you can find which traces the history of the development of the like button. So previously it was thought of being an awesome button, and then it moved on, took on various guises, and now it is called the like button. These are the guys who have designed it. And now they actually have people whom they have hired to make sure that they don't spend too much time on it. Perhaps this speaks something about the drawing power of these social networking sites. Okay. Another one, now this is where it gets really scary, but I want you to read this. So this is, okay, let's see if you can take a guess on who could have perhaps done it. So when you text a friend a congratulations iMessage, you get confetti falling on the top. So this, remember, all this is still on your cell phone, right? This is all virtual. We're not talking about real confetti that is falling. This is called UI sugar, so user interface sugar. Okay? These things, they are being taken to a whole new level when you're using bakery-related metaphors in designing technologies on your smartphone apps. So this statement was made by Dr. Coombs, who has a PhD in neuroeconomics, and he is the founder of a company known as Dopamine Labs. If you actually look at this website, it's called usedopamine.com. This is the website of the company that he's founded. They actually have a 10 or 15 page PDF document that lists the case studies of companies that have used their application. So if you actually look at that case studies document that you on their website, he gives you a lot of the fancy numbers. Oh, there's like a 50% increase in the number of people who spend time on my site, on my app, in different domains, healthcare. It could be various other things. So the repeat customers for this person seem to be in the healthcare domain. You have apps that will manage how many steps you have walked in a day, or whether you have taken your meals on time, and what have you eaten this day, and so on. So this app that was founded by this particular company enables you to, the idea is that it enables the user in making sure that these targets are met. The question is, what is the premise of designing these add-on applications? Is there a science to it? He also has another company called Space, where he provides a solution to make sure that you don't spend too much time on these sites. Okay? So he's addressing both sides of the coin. He's giving you a provision where you spend more time on your app. He's also giving you a solution that will wean you away from these things. So, I mean, that's technology for you, if you will, and what people can actually do with it. Yeah, you had a question.
Just a thought, but doesn't this have like a long history, and in terms of its linkages with the advertising industry, and even at the turn of the previous
I don't deny that. See, again, I don't deny that at all, but what is crucial here is the rate at which we are able to consume it. See, your advertisements were, they run for 30 seconds, and maybe you don't see it for another hour. And now you know that, if let's say you're on any of these cable TV channels, you know that when an ad comes on, you can switch to another thing. And sometimes these guys even give you a timer at the beginning, a timer at the top that says how many more seconds are left before your next series or whatever you're watching starts. So these are cues. These are cues that are provided. And you can turn them off, right? I mean, you can switch your channel, which is what I'm sure you invariably do. Like in between overs in a cricket match, you know that there is going to be an ad, so you'll switch to something else. But these technologies that you find on your smartphones don't have any of those things. There is nothing that says, okay, stop doing this. So I seem to be providing a very dystopian view of Silicon Valley in general, what social networking sites have actually made people, or what state they have brought them in, but there are also people who are providing the necessary checks and balances. And one of these is Mr. Harris. He's been termed as the conscience of the Silicon Valley. He was actually with Google for a long time, and he published a memo which basically raised these concerns. His idea was, look, why is it that we are spending so much time on these sites, on these devices? And this person actually has some solutions. You can look at his website that I've cited here. to see the various solutions that he offers in order to make sure that the use of these social networking sites does not have to be addictive. He even gives guidelines for technologists and user interface designers in how do you ensure that these sites are actually not addictive as they currently are. So he calls his iPhone a slot machine in my pocket. So you can see the direct relationship between what the development of gambling machines and what you have these days on your social networking sites. This is the case study bit about and bringing the relation between an extensive study that was done in the domain of gambling and its analogies and similarities in social networking sites. Now let's try to understand why is it that technology has been so successful in actually making sure that this happens. So from this now we'll be, okay, before that there is just one slide on the social science aspects of these devices. Some of the theories that have been proposed by social scientists themselves is the transactions between humans and machines that unfold at a greater level of intimacy. Okay, so this is how technology this is the point to which technology has come, and this enables them to create a personal buffer zone against the uncertainties and worries of the world. Okay, so we have seen all those statements that were made by gamblers in the first few slides. People said, I want to be in a trance, leave me alone, I want to get lost in it, and so on. So why is it that, from a social science point of view, what is it that these technologies are contributing, and why are they doing this? Why is it that gamblers or people on social networking sites take to it like fish to water? Okay, and then again, from a socio-technical point of view, the assemblage, as my colleague called it, so they hold players in a state of uninterrupted motion to channel experiential effect. So it's all about your experiences. So that was an earlier point that I had, is the technology companies want to engineer experiences, and this is by effects. Okay, so hence the title of my talk is affected feedback. So the feedback that you get from these, either the gambling machines or your social networking site, is affected. It is not natural. It is something that has been developed through technology. Okay, so it's about experiential effect, and again, if you look at it from a capitalism point of view, it's again distinguished by deriving value on these effects. Like Google or any of these companies or even Facebook does not charge you to be a part of the system, right? There's no money that is involved. You're not paying anything out of your pocket, but they give you experiences. They tell you what your friends are doing, what your family is doing, all the photos that they've uploaded, and so on, and out of which they derive monetary value. Okay, so again, this again ties in very closely with the privacy issues, what data it is that you're sharing with each of these sites, your notion of identity when you share such data, whether advertently, inadvertently, we don't know. So it seems like these guys have a lot going in for them. You know, there is a lot at stake, even though they provide these services for free. And that seems to be what, again, like people who look at it from a capitalism point of view have their opinions on these topics. So this is, I think, something that's again slightly more profound. Just leave it to you to read it. But the only thing that I want to bring your attention to here is they express the social forms that are capable of generating them and using them. So it's not that somebody is actually enforcing you to use these new technologies, but it is what society wants. Okay, it's what you and I want, which has led to the development. Now imagine you're traveling somewhere and you have a 2G connection, but you want to check your Facebook. I'm sure you'll be like really irritated because it is so slow. Your photos are not loading. And look at even the advertisements that companies seem to be bringing out these days. You know, you have an elderly couple, maybe as old as my parents, who are traveling somewhere, and some company says, I'll give you 4G coverage wherever you are, so that you can share all your photos and so on. So it seems to be a requirement more from our side, from our social side, rather than simply a bunch of technologists or mathematicians sitting somewhere and saying, look, this is what is good for you. So it's a colluding, it's an act of collusion, both between society, which needs these things, as well as the people who are actually able to supply them. So again, this is a social science element, because we are trying to work in an interdisciplinary effort. Can't be just people working in silos. What lessons can we learn from these observations in actually the development of systems? Okay, so we'll now move on to some hard science. basically from behavioral psychology and a bit from neuroscience. So why is it that these technologies have actually been so successful? This is primarily because of a lot of fundamental research that was done in the topic of behavioral psychology, primarily called operant conditioning. So in operant conditioning, there are several terms that are typically used. There is reinforcement, there are reinforcers, and a system that was actually developed to demonstrate this idea of operant conditioning is the Skinner box. Skinner was a psychologist who was on the faculty of Harvard for a very long time, and these ideas were actually demonstrated in about 1920s. I have a small video that will kind of explain what these things do. So the idea here is that an organism learns from the consequences of its own actions. Okay, so this is the premise of operant conditioning. So a dog will stand on command if it had been fed before and then asked to stand. So the cue here, so the reinforcer here is the dog is given food and then it is asked to stand, and then the next time you ask it to stand, the hope is that it will get that same food that it actually enjoyed in the past. So a rat pressing a lever in the box to obtain food. So this is the most primitive example of a Skinner box, and what has been observed here is that each time the rat presses the lever and gets some food to eat, all it does after some time is it just keeps pressing the lever continuously. So the time difference between each press of the lever reduces considerably, and at some point of time all it does is just keeps pressing the lever. So this has been termed as a law of effect, which was actually termed, this was proposed much earlier than Professor Skinner. This was by another gentleman called Professor Thorndike. So this was, this can be cited here. So here I have a video. It's about 2 minutes long, but I think you'll find it interesting.
Can pigeons read? This one gives every indication, because he's been taught to distinguish between two words and to behave appropriately. He's learned his different response to each sign by being rewarded with food. So the bird isn't acting independently. Its behavior is shaped by controlling its environment. The first task was to isolate an individual piece of behavior and see how that could be changed. Skinner did this by keeping individual pigeons at about 3/4 of their normal weight, so that the birds were always hungry, and food could be used as an automatic reward. The pigeon was studied in a uniform box, one it quickly grew used to. One piece of behavior, pecking a coloured disc, was measured on a graph. The pigeon learned that pecking the disc produced a reward. Then the behavior of pecking could be studied in relation to how often that reward was offered, or in Skinner's terms, what was the schedule of reinforcement.
The main thing is what we call schedules of reinforcement. Reinforcement is what the layman calls reward, and you can schedule it so that a reward occurs every now and then when a pigeon does something. We usually use a response with a pigeon pecking a little disc, a little spot on the wall, and you can reinforce with food, but you don't reinforce every time. Perhaps every 10th time, or perhaps only once every minute or something like that. There are a very large number of schedules, and they have their special effects. And there is a good example of how you can move from the pigeon to the human case, because one of the schedules which is very effective with rats or pigeons is what we call the variable ratio schedule, and that is at the heart of all gambling devices, and has the same effect. The pigeon can become a pathological gambler just as a person can. Now, the fact that we found that out with pigeons and could prove it by removing and changing the schedule makes it easy for us to interpret the case with the human subject. We don't say that the human subject gambles to punish himself, as the Freudians might say, or gambles because he feels excited when he does so. Nothing of the sort. People gamble because of the schedule of the reinforcement that follows, and this is true of all gambling systems. They all have variable ratios built into them. So what we've learned from the pigeon, it made it possible to interpret this vast field very effectively.
Okay, so you saw that was Professor Skinner himself giving that talk. So this is actually what I have shown you here is only half of the entire video, and I've done that on purpose. so that moving in a little ahead, you can actually see the other part of the video. So what you could see here in the brief interview that you saw with Professor Skinner is the concept of the reward system. Okay, so when the pigeon pecked at the red dot, it would get food. And you also saw the earlier part where you think that the pigeon could read based on whether you showed peck or turn or whatever. So like this is what is conditioned behavior. Okay, and all this is enabled primarily by rewards, which are both positive and negative. Now the most important thing that was found in these experiments is the question of schedules of reinforcement. So the idea that was found was if you keep giving a reward continuously, after some time nobody is really bothered about it. I mean, you know that if you press a lever you will get food, so you'll just press the lever only say when you're hungry and not compulsively. Okay, so here we are talking about compulsive behavior, and that is where the variable ratio schedules of actually giving a reward becomes very important. So slot machines and social networking sites basically follow this variable ratio schedule. You don't know what is going to happen next. I mean, that's why we are always in this mad rush to either press a like button or upload a photo or whatever it is. It's not something that happens continuously. Like even the behavior is only reinforced after an unpredictable number of responses. There is definitely an average, but it is not something that follows a fixed pattern. Okay. So what are the sort of rewards that are expected? So it could be in the form of sound or something that is pleasing to the eye and so on. And in the case of gambling machines, the thing that was observed is the concept of a near miss, which I explained to you what it was. You saw those reels that were spinning in the video. If you actually read this particular paper, they talk about how the technologies that have been used in the development of slot machines can also be used in the design of casual games. All your video games, multiplayer games that you find these days. So I think that video was quite self-explanatory to give you a behavioral psychology background to why is it that gambling machines and social networking sites have been so successful in keeping us hooked into using them for a long time. So there are also several addiction theories that have been proposed to explain why can we understand and explain these behaviors. So here are a few of them. So there's something known as a withdrawal-based theory. There's aberrant learning and incentive sensitization. So withdrawal-based basically says that look, a person has actually tried this drug or the use of these sites before, and now there is a certain amount of withdrawal, and there is a displeasure that is associated when you're in withdrawal. Okay, and in order to ensure that you don't face that discomfort again, you go back to keep on using this. Okay, so this is negative reinforcement. Now the simplest example that I can give for positive or negative reinforcement is sometimes when I play with my son. When he does a good job, maybe when he's colored his drawings very neatly, I may say he's very good, I may give him a chocolate or something like that. That's positive reinforcement. So the next time he's given the same task, he would do it well because I know that he knows that I want to tell him that he's done a wonderful job. Negative reinforcement, on the other hand, which is something that people work towards avoiding, is say when I talk to him in a very stern voice, or I scold him because he's done something naughty. Now he wants to make sure that I don't take that tone of voice again, or I don't become very strict with him again. So that's negative reinforcement. So people change their behaviors in order to ensure that one of these two things happens. Either you want to feel your reward should be positive in nature, which makes you feel happy, which is why the designs of these technologies have been so successful. On the other hand, you also have negative reinforcement. You don't want to feel uncomfortable for a very long time, and then you go back and get the same high for a long time. So again, aberrant learning is again another theory which says that the actual neural circuits in our brain become altered with repeated use of maybe a drug. In this case, these have been proposed in the context of actual chemical drugs. But we can see now a very close similarity between drugs that have been manufactured chemically as well as technologies themselves in giving you these same highs. Okay. The other one, so I've kept this at the very end because this now gives me a connection to the final part of the lecture, which is on the neuroscience background to explaining addiction, is the so-called incentive sensitization theory, which says that there are two distinct areas in the brain. One is called wanting, the other is liking. And when we have compulsive behaviors, or one way to explain addiction is that the wanting part of the neural circuits in our brain become more stronger. So you really don't like what you're doing, but you want to do it for whatever reason. There are changes that get affected in the neuronal circuitry. Primarily, this has been identified as the part of the brain which sees the most change. So this is the mesolimbic dopamine systems. So this is now my connection to the neuroscience part of the lecture, where we can, so behavioral psychology again helps us understand why these things happen to some extent. I mean, you saw the last line in the talk that we just saw. So where he says that, look, I can explain behavior simply based on changing the schedules of reinforcement. Can we go a level deeper and try to understand why is it that the human brain actually acts the way it does in acting on these variable reinforcements? And what we find is that the culprit to all these issues that we see here is dopamine. Okay? So this is now my connection to the neuroscience part, where we try to explain why is it that this happens. So research has identified that the dopamine, which is a neurotransmitter in the brain, is connected to the reward system. Okay? So this is something that is generated, it's a chemical that is released in the brain, and this is what makes you feel happy. So dopamine and its associated systems in the human brain is what has been identified as the reward systems. This is basically what makes you feel happy, the release of these particular neurotransmitters. And now you can see the connection between the name of the company, that the neuroeconomist that I had mentioned earlier. The name of his company is actually Dopamine Labs. Okay? And dopamine is the neurotransmitter that is a part of the reward system. Although it forms a very, very small part of the brain in comparison with the other things, it is what actually drives us to do many things. And it has been identified that this is also related to so-called human intelligence, the way you and I know it today. The release of these neurotransmitters, evolution has brought us to the stage where it is the release of these neurotransmitters that has enabled us to come to where we are. You remember that the picture that Professor Manohar had presented earlier about the chimpanzee holding a sharpened stick. So he said that the monkey actually throws it away after it has used it, right? It doesn't use it anymore after it has eaten its fill. Have you seen us throwing away any of the tools or the instruments that we've used? No, because we know that if we use them again, we will get some reward. And this is where the whole point of memory and learning and all these issues are tied in together, along with the dopamine systems, the dopamine reward systems in our human brain, which enables us to keep on doing the same thing for a very long time. Okay? So this particular neurotransmitter is typically released when you have stimuli, which could be in the form of very tangible rewards like food or water. It is also and other such rewards, and then there is a suppressed activation in the case of averse stimuli. So this is what we call as negative reinforcement, something that you don't want to do, something that you don't like. In such cases, there is not much of an activation of this particular neurotransmitter. This is an equation that has been identified that has been proposed to explain the release of this particular neurotransmitter. There's a reason why I have it. I have this here. So if you look at the phrases, it says response is reward occurrence minus reward prediction. Okay, so I'll come into trying to explain the theories that have been proposed in the context of prediction in the human brain. So the dopamine has been identified to follow some sort of an internal clock. Okay, so if at some point of time a stimulus is produced and then there is an associated reward with it, say after a certain time duration, that time duration is actually recorded in our brain somehow. And the dopamine is released again when that same stimulus is presented after the same interval of time. The neurotransmitter is released because it knows that this is what is going to happen. You can play havoc with this by changing the schedules. You don't give it at exactly the same amount of time. You delay it. You vary the time when this reward is actually given. And this is what affects your dopamine response. In the case of learning, so when the human organism has actually learned that if I do these things, this is the reward that I'm going to get over a certain time interval, if the time of occurrence and the time of prediction is the same, you can see that the response is basically 0. I'm not going to feel happy if I know that this is going to be fairly predictable when I get the rewards for this particular, and I have predicted that it will happen at this amount of time. But when you vary the ratio, that is when you will see changes in the dopamine response. And this has been investigated experimentally using the latest techniques that are available. And there are strong results, strong correlations which show that it is these systems that basically have brought us to where we are today. And this is what technology has been using in order to make sure that people spend a lot more time on these devices. So the activation has also been seen in near miss situations. So I told you that the virtual stops on these gambling machines were chosen in such a way that you get a near miss feeling. It's like you almost won, but you're not there. There is experimental evidence to show that dopamine is released, which enables us to plan our future actions. You can find a lot more information in these papers. I've selected these particular papers because to some extent they don't get into very complicated details about the various aspects of the human brain, but they give kind of a bird's eye view of the various systems that have been identified in the human brain to explain such activities primarily related to dopamine.